Okay guys, Assalamualaikum and good morning. Boleh dengar ke suara saya?
Dengar, sir.
Okay. Alright, so as discussed last night, okay. We will start our class at 9, so lebih sikit tak apalah. Saya ada hal sikit tadi. Okay, regarding your tutorial 1 last week, which we are not able to complete them within the stipulated time lah, because you haven't completed the binary number yet last week. So I understand that you have already completed the binary number as well as your logic gates for this week lah. So for the tutorial question 1B and question 2, I have upload here for you here. Tutorial 1, L01, B03, B. So this is the video. Okay, the first one, A, is the one that we did last week. The second one is the solution for question 1B and question 2. So you may refer to my video, this one, which is this one, the second one, regarding the solution for tutorial 2, tutorial 1, question 1B and question 2. Okay, so saya dah ada video dekat sini, you boleh check solution dia dekat situ. Or you can go to the tutorial punya tab ni. I have already shared the solution for tutorial 1. So it means that the solution for all three lah. Tutorial to question 1A, and then this one is question 1B, as well as for the question 2. Okay. So the solution is here, and then if you couldn't understand the solution, if you have any questions, you can refer to this video. Okay, they are the same thing, just that yang ini saya terangkan lah. Okay, ini saya tunjuk dekat you all lah. Sekejap. Okay, so ni solution untuk 1B sehingga question 2. This is the video. Tadi saya ada share dia punya solution pun ada. So it's up to you which one you prefer, or if you can, you also can use both of them. Should you have any questions, kalau you tengok mana yang you try buat tak dapat, or your answer is different from mine, or you need my help to make sure that I can teach you to I can show you to make sure that you understand. Just let me know, okay? Mana-mana tak faham, mana-mana tak dapat, apa-apa yang saya share ni you tak boleh nak tangkap, just tell me. Okay, I will help you. Right? So that is for the tutorial 1 lah. Okay, so for today we will continue with tutorial 2, which is the logic gates. Okay, there are 7 questions and I happen to yeah. Tutorial 2 and the solutions. Okay, so today we will discuss about logic gates. So this is basically very simple lah. Okay, if you have your notes, then you should be able to answer the question easily. Okay, so kita tengok satu-satu. The first one is to draw all 7 symbols of basic logic gates, their description and their Boolean expression. Okay, so Boolean expression ni saya rasa dekat nombor 4 ni pun sama. So tak apalah, either you jawab dekat nombor 1 pun boleh, ataupun you nak just straight dekat nombor 4 pun no problem, sama sahaja. Okay, so draw all 7 symbols of the basic logic gates and their description lah. Senang. Boolean expression ni kita jawab dekat sini kan, dan dekat nombor 4 pun kita jawab juga, nombor 3 dan nombor 4. So these are the symbols of the 7 gates: and, or, none, no, exclusive or, and not. Okay, so they are very easy to be memorized. Untuk you ingat sangat senang. Just make sure you don't get confused lah. Okay, so none ni adalah not kepada n. So just draw an AND gate, just add another bubble dekat depan tu untuk not ni, so dia akan jadi NAND. The same goes to no lah. Okay, so this is the description. For AND gate, the output is at logic 1 when and only when all its inputs are logic 1. Otherwise, the output is at logic 0. So itu dia punya description lah. Dia perlukan kedua-dua input dia satu, baru output dia jadi satu. Kalau dia ada kosong je, automatically dia ada kosong. Sebab apa? The reason why is N is acting as how multiplication did lah. Pendaraban. Macam mana you buat pendaraban. So, any numbers you multiply with 0 will become 0. Okay, just one multiple with 1, you will get 1. Okay, so that is for AND gate. For OR gate, output is at logic 1 when 1 or more are at logic 1. So if all inputs are logic 0, then the output will become logic 0. So for OR gate, it is acting as how additional is in our daily life lah. Means that dia sama macam penambahan. So whenever you have 1, okay, and then if both of the inputs are 1, or you have 3 input, for example 4 inputs, all are 1s, then dia akan jadi 1. Or either one of the input is 1. Tak kira lah ada berapa banyak input pun. Okay, walaupun ada 4 input but only 1 are 1, dia ada 3 are zeros, it still will become 1. Okay, so just remember, in digital electronics, there are only zeros and ones. Kita tak ada 2, 3, 4, 5. There are none of that numbers will be used. Okay, so that is why we are only utilizing zeros and ones, the binary numbers. Okay, so O ni macam penambahan. NAND gate, output is at logic 0 when and only when all its inputs are at logic 1. Otherwise, the output is at logic 1. Okay, so basically NAND gate is the reverse version of AND gate. So whatever you obtain in AND, you terbalikkan. So sekarang ni, if you have any of the inputs 1, which is, no. If you have any of the input to 0, then the output will become 1. If both of the input is 1, then it will become 0. So, apa yang you dapat dekat N, you terbalikkan je untuk none. Okay, NOR gate, same applied for reverse version of OR gate. So, output is at logic 0 when one or more of its inputs are at logic 1. If all inputs are at logic 0, the output is at logic 1. Okay, so if you have, for example, 1, 0, which is 1 in OR gate, for NOR gate, it will become 0. 1, 1 also, 1 for OR gate, but it will become 0 for NOR gate. Okay. Exclusive OR, output it is at logic 1 when one and only one of its input is at logic 1. Otherwise, it is 0. So, you should only have 1 at your input to have 1 at your output. Okay, so salah satu daripada input itu 1, baru you dapat 1 dekat output. Kalau tak ada kat 1 langsung, dia akan jadi kosong. Kalau ada 2 1, dia akan jadi kosong. Exclusive NOR, dia terbalik kepada exclusive OR. Okay, output is at logic 0 when one and only one of its inputs is at logic 1. Otherwise, it is logic 1. Similar to exclusive OR, but inverted. So, sekarang you perlukan both of the input are the same level, baru you dapat output dia 1. Which is, kalau input dia 0, 0, baru dia jadi 1. 1, 1, then the output will becomes 1. If it is the input is 0, 1 or 1, 0, then it will becomes low. Okay. Right. Then the last one is the NOT gate. So this is the only gate which only consists of one input. The rest ni minimum of 2 inputs. But NOT gate, you should only have 1 input. So the output is at logic 0 when its only input is at logic 1. And at logic 1 when its only input is at logic 0. So that's why it is called an inverter. So it inverts whatever you applied to the input. You bagi 1 dekat input, output jadi kosong. You bagi 0 dekat input, dia punya output input dia kosong, output dia akan jadi 1. Okay, so that is the description as well as the drawings lah, dia punya logic diagram. Okay, alright, so they are okay, very straightforward lah. So make sure you just know untuk membezakan lah which one are they. Alright, okay, so that is number 1. Number 2, obtain the truth table for all gates stated above. So the truth table is basically what has been described in the description. Okay, so AND gate adalah operation pendaraban. So whenever you have 0, output will become 0. Both inputs 1, so only will becomes 1. OR is equivalent to additional, penambahan. Ada 1 je, semua jadi 1. Tak ada 1, then it becomes 0. NAND inverted of N, okay, 0, 0, 0, 1 to becomes 1, 1, 1, 0. NOR is the inverted of OR, so 0, 1, 1, 1 becomes 1, 0, 0, 0. Exclusive OR should be 0, 1, 1, 0 for 0, 0, 0, 1, 1, 0, 1, 1. Exclusive NOR is the inverted of exclusive OR, so dia akan jadi 1, 0, 0, 1. Okay, and then NOT, if the input is 0, output will becomes 1. If the input is 1, the output will becomes 0. Okay, alright. Then regarding the truth table, always make sure when you are arranging the truth table, okay, the input should be listed down like this. Okay, 0, 0, 0, 1, 1, 0, 1, 1. Which is 0, 0 adalah kosong, 0, 1 is 1, 1, 0 is 2, 1, 1 is 3. So 0, 1, 2, 3. There is a reason why we arrange them like this lah. So make sure you always arrange them this way. Okay. Then number 3, the Boolean expression of a NOT gate with the input of K is, apa dia punya Boolean expression? Okay, when you apply input of K of a NOT gate macam ni kan, you apply K dekat sini, then the output will becomes the output will becomes K bar. Okay, sebab contohnya macam kosong, input kosong, output dia akan jadi 1, iaitu kosong bar lah. Kosong bar tu maksudnya terbalik kepada kosong. So terbalik kepada kosong adalah 1. So if you apply K, then the output will becomes K bar. Okay, kalau you apply Z, then dia akan jadi Z bar lah. Okay, so that is number 3. Number 4, the Boolean expression of other 6 gates when with the input of X and Z. Okay, dia nak X dengan Z, saya bagi A dengan B pula. So you just change lah. Okay, dekat soalan ke you tukar sini kepada A and B, ataupun dekat sini you tukar X dengan Z. So either way, tak ada masalah. Saya cuma tak ikut dia punya variables. Okay, the question asks X and Z, but I'm using A and B. So just assume X is equivalent to A, Z is equivalent to B. Okay. So for AND gate, the Boolean expression is A dot B. NOT gate OR gate is A plus B. Okay. NAND gate is A dot B long bar. Maksudnya AND gate ni. Okay, saya letak bar dekat atas. So that will becomes NAND gate. And then this one is, this is NOR gate ni, saya typo lah. Namanya. I'll change the bukan the OR gate NAND. No. Okay. So this supposed to be NOR gate ya, tapi saya tertypo, saya letak NOT pula. Okay, so NOR gate, it is equivalent to whatever you obtain in OR gate, and then you barkan dia. Sebab apa you bar? Sebab dia ada NOT gate dekat depan dia. Ya. Okay, so nanti saya upload yang output pula. Solution yang baru ni. Ada typo sikit. Okay, and then exclusive OR. So the symbol is basically this one lah. You letak satu plus and then you bulatkan plus tu. That is the symbol of exclusive OR gate. Okay, so A exclusive OR B. Exclusive NOR, you use the same as how you have written down for exclusive OR. Just add another bar on top of it. But the bar, all of this bar, the exclusive NOR, the NAND gate and the NOR gate ni, bar tu kena one straight line for both of the variables. Or ada berapa variable yang you pakai? Kalau ada 5, dan 5 lah. So semua tu dalam satu line lah. One line bar. Tak boleh pecah A bar exclusive or B bar. No, that will becomes another gates. Yang itu akan jadi gate yang lain. So dia akan jadi salah lah. Okay, so this is the Boolean expression. First one tadi, number 3, that is for inverter, not gate. Just terbalikkan sahaja. Okay, but always remember, inverter ni hanya ada satu input sahaja. Okay, dia tak boleh jadi lebih daripada satu input. It's only one input. Okay, number 5, given the following input stream, obtain the output of NOT gate. So you ada satu input stream macam ni. So like this. Okay, this is the input stream. So apa dia punya output stream sekiranya you apply this input to a NOT gate. So what happens, everything will be inverted lah. So 1011 akan jadi 0100, 0010 akan jadi 1101, 111 will becomes 000. Okay, so very simple, just invert them. Whatever you, okay, tengok ni NOT punya truth table. Whatever input that you are supplying to the NOT gate, it will the output will becomes the inverted version of the input tadi. Kalau kosong jadi 1, 1 jadi kosong. Okay, then number 6, given the following input stream, obtain the output of the following gate for AND or NAND NOR, exclusive or exclusive NOR. So saya bagi sini input lah. There are two inputs, input 1 and input 2. 1, 1, so AND gate jadi 1, OR gate 1. NAND kosong, NOR kosong, exclusive OR kosong, exclusive NOR 1. So how do I obtain this output? From this truth table. Tengok dekat satu-satu ni. Okay, 1, 1, 1, 1. Semua yang 1, 1. 1, 0, you will get 0, 1, 1, 0, 1, 0. 0, 1, you akan dapat 0, 1, 1, 0, 1, 0. So, sama. Column 2 and column 3, you will be having the same output. Column 4, 0, 0, you akan dapat 0, 0, 1, 1, 0, 1. Okay, so basically, saya extract this data from truth table lah. Ni lah, 0, 0, 0, 1, 1, 0, 1, 1. So, sama je. 0, 0, 0, 1, 1, 0, 1, 1. Okay, and then yang ni 0, 1, so sama dengan ni lah. Then 1, 0, then sama dengan ni. Okay, so macam mana you nak dapat isi dalam ni? Tengok dia punya input and then dapatkan output dia dekat truth table. Okay, so it will be much better if you can rememberize this truth table lah. Basically senang je nak ingat truth table. Nanti you get along the semester, nanti you ulang-ulang pakai, nanti you akan ingat lah the truth table tu. Right. Okay, number 7, obtain the Boolean expression for the following diagram. So saya ada this diagram. What is the Boolean expression, which means the output of the circuit? So X lah. So for this one, X is equivalent to, this is AND gate, so AND kan A dengan B, saya akan dapat AB, so A dot B, OR it with C, which is inverted, so C bar. So saya akan dapat X equivalent to A dot B plus C bar. So A dot B, ini OR dia jadi tambah, N dia jadi darab, dia jadi dot, C saya invert, so dapat C bar. Okay, second one, this is OR gate, so dia akan jadi penambahan A bar plus B, so saya dapat yang ni A bar plus B, dia akan NAND-kan dengan C. Okay, so saya darab dulu dengan C, lepas tu saya barkan semua. So basically macam mana dia akan jadi adalah, kalau alamak saya salah, so salah tekan pula. Okay, saya tunjuk cara dia yang ni lah. Okay, cara tulis yang betul. Sebab dekat dalam Word saya nak letak bar tu, dia akan consume time. So saya just guna ni lah simbol ni. So what will happen for this one, dia akan jadi macam ni. A plus B dan C. Alah. A B dengan C. Okay, so basically this is how okay, so ada A bar, A bar, lepas tu C, lepas tu ada kurungan bar, dan dia akan jadi macam ni. Okay, so this is how this equation looks like. A bar plus B, N kan dengan C, and then bar everything. Sebab bar ni ada dekat luar kurungan. So that is how you obtain your output lah. Macam mana you baca saya punya output ni, yang bar ni maksud dia, yang tanda atas ni, apa ke nama dia ni, bukan exclamation mark, quotation mark, single quotation mark. Di single quotation mark ni adalah bar lah, saya tandakan dia sebagai bar. Okay, saya tak buat macam ni. Kalau macam ni saya nak kena letak line ni, saya di consume time, akan memakan masa masa saya buat solution tadi. So saya just guna tanda single quotation mark. So B is equivalent to this one. Kalau A, it is equivalent to simple je lah, A dot B plus C, and then you bar kan C. Okay, so that is for A, that is for B. Okay, and then third one is this one. Okay, you have an AND gate, OR gate, and AND gate. So A, B, you get the first one, and then you AND kan dengan output of this OR gate, set of OR gate C and D. So C plus D. So you akan dapat A dot B dot C plus D. So very straightforward. Tak ada bar, tak ada apa-apa. Okay, so ini and. Basically yang ini you boleh, these things, this equation semua ni, you can simplify them lagi sebenarnya. Boleh disimplifikan. Tapi itu nantilah next topic. Bahagian boolean algebra baru kita belajar. As for now, kita concentrate dekat logic gates dahululah. Okay, and then the last one, you have an AND gate, OR gate, and another OR gate at the output. So this will be A, B, plus C, A bar. So A bar, C. A bar plus C. So you akan dapat A, B ni for this AND gate. A bar plus C untuk this OR gate. Tambah ni untuk this OR gate. OR gate yang belakang ni. So X equivalent to A dot B plus A bar C. So if you need to write them down, dia akan jadi A dot B plus A plus C, where A is bar. Okay, so that is how it should written down lah. A plus B, A dot B plus A bar plus C. Then you get your output. Alright, so that is for question 7. So all of the solution has been discussed lah. They are very straightforward sebenarnya. Okay, one until question 1 until question 4 is basically remembering punya method. You kena ingat. Question 5 you kena analyze, but a very low level analyzing, as well as question 6 ni lah. Question 6 ni you kena analisis untuk dapatkan dia punya output. You kena tengok, okay, satu-satu untuk AND gate dapat apa, and so on. Okay, but it is a low level analysis lah. Question 7 also analysis, tetapi you kena upgrade the level of analysis daripada question 5 and 6 tadi lah. Yang ini you kena tengok sini dapat apa, sini dapat apa, baru you dapat output dekat X, penghujung dia sekali, what is the total output and everything. So you perlu buat analisis lebih sikit untuk dapat output dari, untuk dapat jawapan soalan 7 ni tadi. Okay, so that is it for tutorial 2. Okay, so the solution I will share it later dekat dalam VLE. Saya dah upload dah sebenarnya the solution. Okay, here I have the solution for tutorial 2 already, but It is just that I have another class after this, so I need to go through with them first before I can share the solution. Okay, kalau saya share sekarang nanti, diorang dah dapat jawapan, so diorang tak akan try. Right, so that is almost what I want to, inilah, tak nak benda tu berlaku macam tu lah. Okay, so video for this class today, I will upload it later dekat bawah ni, so you can refer back lah for your future reference. Okay, then I will share with you your attendance for today. Please scan your attendance, eh. Okay, you guys have scan your attendance. Dah scan ke attendance? Berapa orang ni? 14 so ada 13 orang lah. Another one, siapa belum scan?
Saya tolong tandakan saya pun tak ada scam tak?
Siapa tu nama?
Muhammad Fikri Farhan.
Okay. Okay, the rest dah kan? Okay, any question you guys? Ada soalan ke? No question. Tak ada, Okay. Nanti bila you buat, dah tengok solution, if you have any question, you can ask me directly lah, direct personal pun boleh, apa, okay lah, whatever methods that you want to contact me, just contact me. I will help you to make sure that you understand lah. Okay. So I think that's it for us today. I will share the solution and this video lecture, this video teaching later today lah. Okay. Right, thank you guys. Assalamualaikum and good morning.
Thank you, sir.
Thank you, sir.
Sama.
Thank you, sir.
Thank you, sir.
Alright.